I'm Brian Newton, and I'm a developer for Linkstream. So, what's your guys' level of familiarity with F#? Has anybody used it at all? Just dabbled in it on like a hobby project or anything? So one person, I see someone in the back doing this a little bit, yeah. So I'm guessing nobody's using it in production today. Or do you know anybody? I looked into it briefly. I couldn't see anybody in Omaha that was using it. I don't know, maybe they're not advertising it, but as far as I'm aware, nobody's using it in production in the area. So, why should you care about F#? Well, according to the Stack Overflow 2016 developer survey, it was the third most loved programming language. And they define that as % of developers who are developing with the language and have expressed interest in continuing to develop with it. Another statistic on there, as far as top paying tech in the US, it's tied for second with a couple other ones. And that was with a minimum of 100 responses among all US developers. Top tech worldwide, it was #1. So, and that's with over 40,000 developers in the top 30 countries by respondent count. So, people love to use it, and it pays them well. Okay, you might be asking yourself, if you're a business, why should you care about F#? So the Jet.com blog explains why they chose F#. They basically were able to get the same functionality with less code, which eases maintenance and reduces bugs. And apparently that's very well known among the F# community. If you've been around there for a while, they said that was a well-known thing. For those of you who don't know, Jet is an e-commerce startup that billed itself as an Amazon competitor, and it recently sold to Walmart for $4 billion. They initially planned to use F# just for their pricing engine, and then they were going to use C# for the web stack, because many of their engineers were object-oriented, had that background. They started working on two solutions, a C# one and an F# one, and eventually it became clear that a switch to F# made sense. Paul Graham says in his essay, The Python Paradox, if a company chooses to write its software in a competitively esoteric language, they'll be able to hire better programmers because they'll attract only those who cared enough to learn it. And for those of you who don't know, Paul Graham is the co-founder of ViaWeb, later bought and renamed to Yahoo Store. It was, I think, one of the first internet startups ever. He also co-founded the Y Combinator seed capital firm. And the Jet.com blog also mentioned that in that same post. Those attending F# user groups weren't doing so to learn the new tools for their day jobs. They were driven by passion for learning, for the language, and for the community. So it was people attending these user groups for F# that are not even full-time F# developers. They just really like the language. And they called that out and said basically developers who attend user groups generally do so because they're passionate about a certain technology. You guys are all here because of .NET. But a lot of times they're full-time in that tech. Jet found that both locally and worldwide, the number of full-time developer attendees were F# full-time were significantly lower than respective full-time attendees for other functional user groups. These were exactly the type of engineers Jet wanted to hire, and there were no companies also betting on F#, so they didn't have to fight anybody for these talented and passionate engineers. In another essay, Beating the Averages, Paul Graham mentioned when you choose a technology, you have to ignore what other people are doing and consider only what will work the best. You can use a technology that your competitors glued immediately to the median language will never be able to match. In that article, he says, the average big company grows somewhere around 10% a year. The average startup goes out of business. Big companies can do what all the other big companies are doing, and startups can't. However, all companies can benefit from tools that give them a competitive advantage. He mentions that ViaWeb was built using Lisp, which is the original functional programming language, and it was their competitive advantage due to its expressive nature and powerful metaprogramming capabilities. They were able to do more with less and consequently beat all their competitors. So what is F#? According to fsharp.org, F# is a mature, open source, cross-platform, functional-first programming language. It empowers users and organizations to tackle complex computing problems with simple, maintainable, and robust code. I highlighted functional first. What does that mean? Functional first means functional by default. Functional is the frictionless happy path. F# is a general purpose, multi-paradigm programming language and supports OOP and imperative programming models. So although it is a functional programming language, it's not a pure, strict functional programming language like you may have heard of, like Haskell or some of those other more academic languages. It just leans functional from the get-go. It's fully interoperable with other .NET languages. However, you can transpile it to JavaScript as well as CPU code. There's even a project that's like a lightweight IDE extension called Ionide that's written in F# and compiled to JavaScript to use as an Atom extension and a VS Code extension. Historically, it's seen the most use in the finance and data science industries, but it's not limited to those industries. It can be used for WinForm, XAML, web apps, and other stuff than number crunching. The tooling can be lacking at times for like designer support and project templates on, like, say you're doing web API, or it has been historically, but usually you just can code your way around that. So what is functional programming? Is it programming that's not dysfunctional? If that's not it, then what is it? So you guys are all familiar with LINQ and async await. Those were both inspired by F# and functional programming. The Lodash and React are two popular JS libraries inspired by functional programming. Elm, with its time travel debug and hot module replacement, and ClojureScript are two functional languages that transpile to JS. Clojure and Scalar are two popular functional languages that run on the JVM. I mean, it seems like nowadays functional programming is everywhere. So what exactly is it? There's a number of different languages and camps in the functional community, but pretty much everywhere you go, you're going to find that functional programming has immutability, first-class functions, function composition, and partial function application. So immutability means never update. Create an updated copy, and that's going to eliminate classes of error, and it makes concurrency possible for mere mortals. Basically, you want to avoid state and use expressions that return values over statements that update memory locations. First-class functions. Functions are values, which means functions can accept functions as input and return functions as a result. Function composition. Functions can be easily composed into new functions. Function composition is crucial to reusability. Most of our OO design patterns are composing objects. So with functional, you're going to be composing functions more frequently. Partial application. Functions can have only some of their parameters supplied at a time and return a new function that takes the remaining parameters. This pairs really nicely with function composition. So functional programming is really about limiting what you can do so that the code can be reasoned about. You should enforce discipline by language design and not programmer choice alone. So you often hear people say reason about code when talking about functional programming. And that means they want to be able to look at a small chunk of code and without looking at the rest of the whole solution, be able to know certain things about it. Most problems I have today are with code that is hard to reason about. I have to look everywhere to understand how that's going to work, and then it's hard to reason about adding parts. Functional programming aims to fix that. I'm going to get to some examples here quick. So what are some of the features I'm going to go over? So F# has too many features for a short presentation. I am mostly covering an interesting subset of the functional ones. It has like 99.9% of the OOP features from C#, but I wanted to focus on functional programming for this presentation. So algebraic data types, static typing with type inference, pattern matching, first-class functions, function composition, partial application, and pipelines. option types, which can help us prevent null references, units of measure, type providers, async workflows, and a bunch more. So algebraic data types, tuples, records, discriminated unions. Last month's presentation talked on tuples and pattern matching. So if you were here for that, it's pretty similar to that. Records are kind of similar to an immutable class that don't have any methods, which F# types are immutable by default and have structural equality and get hash code automatically. Structural equality means that if you have two objects and you compare them, if all their properties have the same values, then they're equal, even if they're different references. And the automatic get hash code implementation means you can easily use them as keys for a dictionary. You might be hearing immutable and always create new. That sounds pretty wasteful, but with tons of memory these days, paired with clever data types and good garbage collection, it's often better than what you would think. So, on to our example. Where's my mouse? I don't need a mouse. Okay, so here you can see the tub1, tub2, tub3. That's the syntax for creating a tuple. The parentheses are optional. So I'm going to highlight this code and run it in F# interactive by just pressing Alt-Enter. So I need my. Does anybody see my mouse? Going to need a mouse. Having some technical difficulties, so I need to display that all.
Wireless mouse, or is it the touchpad?
It's the touchpad. Hold on, I'm gonna log out and log back in. I have it extended. I can try duplicating it. If I can right click. It's not letting me right click.
Anybody have a mouse?
Yeah, this is a mouse related issue. I don't know, I don't see it anywhere.
Go to maybe disconnect video and see if it comes back.
Yeah. Yep, that came back.
Yeah, there it is.
So my laptop does not like that video.
There it is. It's gonna stay.
Let's find out. Okay.
There he found his mouse. Okay, Brian.
Yeah, let's try that. Thank you. Yep. Let's adjust this resolution so you guys can actually see stuff. Or not. So, as you can see here, this is of type bool star int star string, and you can see it just matches up with the stuff that I just created. This is the type information. Notice that I didn't specify any typing. I just did let. It's kind of like var, except with everything in F#. Basically, you're not going to specify types, and the compiler will infer it. So I have a value called tuple or tup1. It's bool int string tuple. So one nice thing about F# types is they have like it's a default printing. So you can pass %a on an F# record, discriminated union, or tuple, and it will pretty print it. Unlike if you call toString on an object, you have to implement it yourself. So again, I said they have structural equality. Right here, I'm comparing tup1 to tup2 and tup1 to tup3. As you can see, tup1 and 2 are true, but tup3 is not equal to tup1. Same thing with object equals. Those both match. As far as reference equality goes, object.reference equals tup1 and 2 is false. So they are different objects, but they are equal, and it was automatically implemented for me. You can see here the hash codes are equal for tup1 and 2, and tup3 has a different hash code as well. So that is tuples. Here's how you do records. So we can define a person record. It has a name and an age property. And then, again, notice here when I'm defining it, I don't specify a type. I don't even specify a type for when I'm constructing it. The compiler figures out the only type I know about with a name and age property with those types is a person, so it knows that it's a person.
Right. Two questions. One, I'm assuming all the base types are the same as C# and other .NET languages. So when you're doing type person like that, is that going to be like a reference, or is it going to be passed by reference or passed by value?
I believe it is a reference type. I think it generates a class, the compiler.
Between those two concepts?
Reference and type. It does. She knows.
Variables, you can actually, there are such things as mutable variables, where you can do it a little bit more procedural, and over there it kind of matters, but is regular because if you pass it whatever by reference or whatever, you still cannot on the person. If you pass it to the function, you cannot change anything.
Can't change the name or change.
Right.
So that's roughly equivalent to a class.
With all read-only properties. Yep. Notice here for person 3, I use the copy update syntax. I'm probably calling it wrong, but basically I can take an existing record, and say I want all the same properties, but I want the age to be 20. So the compiler just does that for you. It's pretty slick. And you can see here I'm doing the same exact, doing the same exact checks as I did before with tuples. Person 1 and 2 are equal, and person 3 is not because it has a different age. Object equals matches the equals check. Reference equality, again, you can see person 1 and person 2 are different references. Maybe this would be better down low. When I was doing this at home, my screen was wide enough that it made sense that way. This might be easier for you guys to read. So, hash code. Again, you can see the 1 and 2 are equal. And then as far as immutability, you can see person 1, I changed the name or the age, and it's still 10. So it doesn't do anything. This actually returns a bool, which I believe is false. Let's see. Yeah. So, and this it right here is the last statement that the F# interactive ran. So basically updating age is false because you can't update immutable properties.
But that doesn't throw a runtime exception.
Nope. It just doesn't do anything. let's see. Okay, so discriminated unions. So I pulled this example from the Microsoft Docs language reference. So discriminated unions are basically a type where each of these discriminators, like rectangle is one, is part of that type. So the type has a number of cases. So a rectangle is basically, this is saying it's a, it has a width property that's a float and a length property that's a float. And this star syntax is saying it's really a tuple, but I'm giving them named values. Circle is a radius, and that's just a float. Prism is a width, and then it has float, or that's a float, so that is a tuple. I'm not understanding that. Oh yeah, prism, there it is. And then it has a height that's a float. So one of these is not named. So there's width, and that's a float, and then comma, just some unnamed float, and then there's a height. So let me show you. We create the type. So here's our type. I have rect, which is, as you can see, the compiler infers that it is a shape. That's its type, and it's a rectangle of 10, 0, 1.3. Again, there's a built-in pre-print functionality for all this stuff. So you can see it prints nicely when you want to check that stuff out. Temp1 and temp2 are equal. Sorry, rect1 and rect2 are equal, while rect temp1 and 3. I didn't update these variable names. I apologize for that, but rect and circle are not equal. That's this comparison here.
Question. In the previous code sample.
Mhm. Oh, I didn't.
This one, on the previous one.
The tuples and records?
Yeah. On this one, Simon, it's actually checked for the equality, isn't it? Because assignment, if I remember right, it's kind of error goes that way.
Yep, that makes sense. That's why it's a bool. It's a check for equality. So the assignment operator is actually this. Oops. And
You should get the compilation error.
see, there we go. And usually, I think whoops. And the F# compiler is actually trying to warn me. This expression should have type unit, but it has type bool. Use ignore to discard the result of the expression, or let to bind the result to a name. So it's saying, basically, this returns something and you're ignoring it. So you have to use a keyword to basically say, I don't care about this value. So it's hinting to me you're doing something stupid, basically. So here, discriminated unions can be recursive types and generic. So here we define type MyList. It's of generic type A. And we define it as it's either empty or it's a cons of head, which is type A, star tail of my list type A. So basically that means I can say cons 1, cons 2, cons 3, empty, and generate a list, or generate my list. You can see it here, my list 1 has that value. It's a my list of int. F#, the compiler will infer, once it knows the parameters for that generic type, it'll show you. So it knows it's my list int. And again, you can see it looks pretty similar here. And then it'll pretty print it for me. Any questions?
I'm sorry about that.
Oh, that's all right. All right, let's hope that this doesn't. Let me try and extend this and hope the mouse doesn't disappear again. Because I have some notes. So F-sharp types can be mixed and composed into bigger types. For example, a record can have a discriminated union as a property, or a discriminated union can have another discriminated union as a case. And you already saw you can recursively define discriminated unions, so it's really powerful and flexible as far as the type system goes. The one thing you do notice is they don't have methods. The behavior is decoupled from the representation of the data. One other interesting thing you can do is have a single case discriminated union, and I'll have an example of that to come later with pattern matching. But that can allow you to compile time check that like an integer is really the type of integer that you're expecting there. You may have like a customer ID, and you basically can wrap it up in that so that you can't accidentally pass it into the wrong function. So, pattern matching. Pattern matching lets you extract values during assignment. And so it lets you take grab the patterns and take pieces out of the algebraic data types. My example won't show matching on more than one thing for simplicity, but you can easily tuple things and match on the tuple or match multiple properties from a record. You can do some pretty sophisticated matches. All right. So here, I'm doing pattern matching out of this tuple. As you can see, the compiler knows that this is an int, and it knows that this is a float, just based off of, it can see on the right side. But depending on how you use things, the compiler is pretty clever with it. Again, I define a simple discriminated union to represent different types of temperatures, and then I can define functions that allow me to pattern match on it. So here you can see this match statement where I say match temp, which is this property coming in, and the compiler is smart enough to figure out that it is a temperature, basically because I'm matching on it and I start using values that are in this discriminated union. I don't have to, I could specify that this is a temperature. But there's no need because the compiler already can tell that based off of how I use it. So here I just say 2F for convert to Fahrenheit. And I match on the Celsius case to extract out the float value that it holds. And then I just run it through the formula to convert to Fahrenheit and wrap it in Fahrenheit. If it's already Fahrenheit, I don't care what the value is. So this basically means don't even bind to it, I don't care. And I return the temp that was passed in. I have the same comparative function for 2 Celsius that just does the corresponding conversions. And then just to make it interesting, here you can see the result of a match statement returns a value. So I can say let result equal whatever this match statement, this pattern match comes up with. And here I'm not wrapping these in the discriminated union, I'm just leaving them as a float. So I get a float out of this. And then I check the result. If it's less than 0, I fail with invalid temp, below absolute 0. Otherwise, I return the Kelvin. And I could have more air handling and stuff in the other code, but I just wanted to show that example. So here is that single case discriminated union I was talking about. And let's say we had a function that prints a customer or prints a customer ID, I suppose. If I want to make it so they can only pass in a customer ID, I can do that by basically using this here. So customer ID, and then I extract the int value into this ID parameter. The compiler matches on that and pulls the value out of it. And now I can print it out right here. This print statement is actually strongly typed. This %i, the compiler knows to expect an int as that first parameter, because that's that. So it knows that if I try and do like, just ignore that stuff and do like 20.0, and that's a float, it's going to tell me float is not compatible with any of these types that I'm expecting. So that's one of the cool things about the formatted printing in F# also. And again, I create a customer ID and pass it in, and the compiler lets me do that. Let's say I just tried to pass in 10 because it's named customer ID. It's going to tell me the expression was expected to have type customer ID, but here it has type int. So again, you can enforce that it's a certain expected type, and that can be handy. Oh, that's another thing I need to show an example of that. So one really cool thing about pattern matching, let's say I just remove this parameter, actually. The compiler notices that I've got an incomplete pattern match. It's telling me that the value Fahrenheit may not be checked for. So it knows when you don't cover all possible cases. You might cover a case and say fail, throw an exception, this should never ever happen, but it can tell you you didn't cover all the possible cases of all the different discriminated union types in this. So it's really pretty slick. And very helpful like that. Okay. On to the good stuff. Functions. So, and you're not seeing what I'm seeing. There we go. So, functions. First class function, function composition, partial application, and pipelining. So first class functions, like we said, functions are values, and they can go into, they can be parameters to functions. So fn is a function that takes unit, which is basically like nothing, no parameters, and it also represents the void type, essentially, more or less, and returns a, which means it returns some type. It's generic. Oops. So we know takes a function is actually a function that takes a parameter that is a function that doesn't take anything, returns some type, and takes a function, returns that same type. So as you can see, the return statement is basically just calling that function. So if I run this, I have two functions. I have takes a function and print something. So if I apply takes a function with that print something function, you can see down here, something was printed to the console. This one returns a function. So if I call that and get this return function, that's a function that doesn't take anything and doesn't really return anything. It's going to have some side effect. I should see something else printed to the, you can see it here, something else was printed because I ran the function that it returned. That doesn't seem that cool. Takes a function and returns a function, can take this function. Inside it has another helper function that calls that function twice, and then it returns that helper function. So here we go. So do it twice takes unit and returns unit, which is basically no parameters and has some sort of side effect. So as you can see down here, it printed testing, testing. So it did do it twice. Function composition. So let's say I have this function that adds 3 to a number that I pass in. Add 3, mul 5. So let's say I want to add 3, then multiply by 5. I could have a new function that calls the first one, saves the result into a variable, and then calls the second one. That might be how you do it. Or I could have add 3, then multiply by 5, which takes an x parameter, composes those two functions into a single function, and then calls that new function that we got from composing that with that same x parameter. So, and this prime syntax is just so that it has a unique name and doesn't collide with that other one. The single tick is a valid identifier for variables and functions. Instead of doing this though, I'd rather just compose the functions and store that off into a value. That is a function itself, and I can call that with the values that I want. So down here, let's wire that all together, and I call all 3 of them and store off the values into a corresponding variable. So they all get 40. So basically that's just, if you have one function that returns a type and another one that takes that same type as its parameter, you can just kind of glue them together and create one function out of the two. Partial application. Let's say I have an add that takes x and y, and a mul that takes x and y also and multiplies them. Add 3 prime, again, just so it doesn't name collide, I gave it a tick. I can say add and 3. It expects two parameters. I have not passed y yet, but it gives me back a function that takes one parameter and returns that integer, basically. Same thing with mul. So I was able to define equivalent functionality just by partially applying. I only gave it one parameter when it needs 2. Again, operators are defined as functions in F#, so I can define this add 3 function in another way. I just put parentheses around the plus, apply 3 to it, and it'll return me the same old deal, add like that. So that actually turns out really handy when you're doing like summations over lists and stuff like that. So you don't have to define a lambda expression that adds left and right parameters. This stuff also works for partially applying DB connections. For example, it's not just inputs to math stuff. It can be logic that you pass in. You can pass in a function that'll calculate something. It's not just like math oriented. It can be very useful in general. So pipelining. What is pipelining? So here's a function that is not pipelined. It takes an x parameter and does a whole bunch of stuff on it. And for each step, it creates a variable and calls the next function in the sequence with that variable. Pipelined. This version uses pipelining. There's a lot less noise. It's basically what is my thing doing? So I take x and I pipe it into add 3. And then I pipe the result of that into mul 5, and I keep going and going. Here I use float and compose it with the square root function from math because this returns an integer, and square root in math actually needs a float, so I had to convert it to a float first. So I just kind of glued those functions together to make things fit. Here I just threw a lambda in because I could, but I divide whatever we have at that point by 3, and then call all the same stuff. So, and as you can see, they're both going to get the same result. So, personally, I think that this version is a lot more readable. It has a lot less noise, and I don't have to think about good variable names for stuff I really don't care about, because it's just one step in what I'm trying to do. It just reduces the cognitive burden. What's this stuff? Oh, that was just saying that the values are the same. So this becomes even more handy for list querying. Right here, I just generate a list from 1 to 10, filter it on being even, reduce it with the plus operator, which basically means sum up all of the evens. That's what this is doing. So the sum of evens from evens less than or equal to 10 is 30. So again, here's that. You can do multiply. You can do any operator that would take. Any questions on that? I know that's kind of a lot. All right, on to more stuff. So, option types. Tony Hoare once apologized during a lecture for inventing the null reference, calling it his billion-dollar mistake. When used with pattern matching, option types can eliminate null reference exceptions. So, options are a generic type that can express that a value may or may not exist. So if it doesn't exist, you use none. If it does exist, you use sum of t, which is the generic type. So you can get null reference exceptions in F#. None is actually null, and I can prove it. Where is it? So, where did that go? There it is. So, null equals none is true, and reference equals is also true. So it is actually just like an alias for the null reference. But for example, to generate sum of string, so this is a string option, I just wrap whatever string I want with sum. So let's say I want to map some string option. Right here I declare to let the compiler help me with this, that it is a string option. I match opt with sum of str to extract what str is. If it's none, I just return none right here. If there is sum, I do another match statement to extract the value, or on that extracted value. When the length is greater than 10, let me zoom out. When the length is greater than 10, so notice this when statement also, I can do, on my cases I can do that to perform additional logic that you can't do an exact match on. When the length is greater than 10, return sum of too long. If the value that I extracted from that string option that they passed in is secret, then just return none. I don't want to return anything. And then otherwise, return whatever they passed in, the original option up here. So that's cool. Let's see what the outputs are. So if I pass in, what was it? If I pass in sum str, it basically repeats that back to me. If I pass in none, it repeats that back. Secret becomes none, and then really long string, I get sum of too long. You know, that kind of sucks though. Why do I have to match on the option? That really has nothing to do with my logic. Well, I could just write a map string which takes the actual string, has the inner logic of the inner match, and then just compose that using option.bind. So that'll give me a new function that basically just has that initial outer match for me. So then I only have to write the logic that I really care about. And as you will see, I get the same results. If I pass in sum of IAMSUM, I get that back. If I pass in none, I get none back. If I pass in secret, I get none. And if I pass in the really long string, I get too long. Again, I just used option, which is part of the option library or module, and bind, and that just takes a function that takes a value and returns, that takes a function that, like this, where it expects this value and then kind of converts it into the option world, essentially. So I can leave this check right here off, these pieces. It just kind of handles that. If it comes in as none, it just continues that on, basically. So, units of measure. Units of measure are basically metadata added to types to annotate the units that you're working with. It provides compile time verification of unit correctness. And one of the motivations for this feature in F# was the 1999 loss of NASA's Climate Orbiter due to a cross-team metric imperial unit mix-up. Let's see the example here. So, to define a unit of measure, you just basically tack on this measure attribute to your type that you define. So here I'm defining some time, seconds and hours, and then distance, meters and kilometers. And as you can see, I'm creating a get distance traveled function that takes a velocity in kilometers per hour and a time in hours. Both of those are floats, but they have different meanings. They are different units. So the compiler knows to expect certain units, and you specify that. So what's interesting is it returns a float of kilometer because it knows that when I multiply something that is in the unit kilometer per hour times something that is in the unit hours, that it can just strip that out, and it knows how to convert those units. So I define a velocity, 80 kilometers per hour, and a time, 3.25 hours. I defined an acceleration just because you can see, as an example, it's kilometers per hour squared if I divide by 2 hours again. But distance traveled is going to be a float with kilometer as its unit. So it's 260. But let's say, for example, I change this into seconds accidentally. The compiler knows that I've got a type mismatch. It's expecting a float of hours, but it was given a float of seconds. So it's not possible for me to mess up these units. You just have to be explicit in what you're doing, and it will get your back. So it's pretty awesome. Looked like, yeah.
Cover, is it like a CLR? Is it all still just a float?
I think that you can't like reflect on it. I'm not really sure. I don't think it's actually compiled in. I think it's just compile time verification. So I don't think it's super dynamic. You can do something similar with those single case discriminated unions, but I don't think you can easily multiply and divide units and stuff like that. I really don't know enough about that, but you seem like you have some input. I don't know.
Sorry. I've been doing that for a long time. Short answer, yeah. It gets erased at compile time.
That's what I thought.
One of the nice actual use cases is not just like mathematical measurements like this.
Mm-hmm.
I've actually seen examples where people will take they'll have different units of measure for like web pages, like the absolute position of the elements on the page, or the absolute position of the element from the top of the window.
Mm-hmm.
And they'll represent those with different units of measure
Mm-hmm.
and do conversions between them. So it's really cool. You can actually do things besides like mathematical operations or currency conversions. Lots of different use cases for these. Yeah.
Sweet. Yeah. But yeah, as she said, that's what I thought. I believe that it is compiled out and erased. It's just you have to know it at compile time. So, type providers. This is like the killer feature of F#. They're similar in some respects to T4 templates, but they're not quite the same. Basically, type providers provide types to your code from external sources such as databases, CSV files and REST services and tons of other stuff. You can write your own. But during design time, you can point it at an external resource and it will generate types for the language service to use. So according to F# Deep Dives, the design philosophies were that it had to be code focused. They wanted to minimize context switching. You should be able to work frictionlessly in F# Interactive. So they don't want you to have to switch to a different tool and run a command like with T4 templates or anything like that. And you should be able to interactively get those types and query against them when you're just prototyping stuff in F# Interactive. Uniform integration. They wanted a single consistent mechanism that used plain old types and no awkward meta programming required. And I assume that they mean no meta programming to consume those types, because creating a type provider, from what I understand, is all meta programming. But to consume them, you don't have to do meta programming. They also wanted it to work with large-scale data sources, must scale to thousands or millions of logical types. Your project may only want a few of those types. So that's really useful in data science when you would be doing that interactive, let me check this thing, let me check that, and I only care about this small portion of this database. If you have to pull in every type generated from the database, it might just crash the whole thing if you only care about one or two things. So they wanted to scale like that. They wanted to be able to use live and evolving data sources, so support invalidation. The language service should help you when the provider recognizes that the schema has changed on the server. Those last two T4 templates kind of fall short in those. And the code focused, I think that was kind of one of their design considerations for that too. It should just be kind of automatic and do stuff for you. So there are many type providers available, including one for SQL Server, and there's even an R one for working with the statistics language R. Let me show you an example. And I believe I have my Wi-Fi. Type providers. So this right here is basically saying if I'm running an interactive, which that's what I'm doing for all of these examples, reference these DLLs. So let's do that. So right here, I'm using the CSV provider to get types for CSV out of this example. So where'd that example go? So here's the example, here's the headers. This is just a CSV file. And the type provider basically reads through that and then determines what types can I generate from this. So you can see I got a type stock that's from this deal. So here I can load this from Yahoo Finance. You can see I did the Microsoft stocks. And I can just print stuff, loop through them. Let me make sure I have connectivity. I do. Let's see if this one worked. Don't require the internet during a presentation. Normally that just prints out like a row of that stuff. And as you can see,
Are you signed information?
I had logged out. Okay, yeah, let me sign back in. What is it?
Net guest, username bguestnet1.
I think it's redirecting me. going to redirect me here. While I wait for that to do that, there's an example that doesn't require internet. So here is a SQL data provider example that connects to my local database. I generated a example demo table that just has like no data in it, but as you can see, so I basically pointed at the data source, provide that to this with some other parameters, and then it can like look through your database and determine what's there, almost like database first T4 templates and stuff. Here we go. I basically extract those values and I put them in a tuple, and so I can query my database using that. Let's change a column. All right. See if I run that again. Does that? I would expect pretty soon here. Let me change this. So this should be telling me that this is renamed. Not for certain what I have to do to get that to, this is one of the last ones I added, so I'm not positive what I have to do to.
You don't save it, I don't think, are you?
Thought I did. Oh, I think I used the function key instead of save. Yeah, I'll close it and call. Yep. Let's try that again. Oh. Okay. Not sure why that's not
You need
updated.
to get the data context.
Yeah, I would expect that that might update. It's supposed to work. What is it doing now? Not exactly positive what I need to do to get that to re-query that. But it should somehow be able to, there's probably like a context.refresh or something that I'm missing out on. Trying to, when I try to go to google.com, it doesn't bring up the, is there like a URL that I can go to try and get that other?
No, usually when you go to the Google or something like that.
Should bring in a login page for the guest management.
Let me disconnect and reconnect. There it is.
What happens when you execute Control-C? Will it bomb out in that sharp exactly?
Let me try.
Bellicon. Add it in the message.
So what did I name it? CD?
Yeah.
Is that? So maybe it's a,
Just for fun, can you maybe rename your variable? Maybe rename the type from SQL to something else?
interesting.
Oh, you didn't select lead.
Not doing so hot on that. Yeah, it's not liking that. What is the pass? B guest.
G, capital X, lowercase w, asterisk, lowercase b.
Chris B. Net one. Yeah, I'm not getting in. B guest net one.
Biggest.
Capital G X W star V. Okay, now I can log. Now I'm in. Let's try this again. So you can see it's printing this stuff out, HLOC. So it's just looping through all the ones that it pulled down from that.
So the state type providers, are they read-only or can you update data? Let's say we bound to the database, can you update
Yep.
data over there?
Yep, you can. Whoop. Where did that go? Getting some sort of, where did that go? Do I have like a third screen? This is really screwing with me. There it is. Where is this? Querying CRUD. So you pass in the same stuff again, get it. That's getting the first one. Let's say you want to update, or let's say you want to insert. So you call the create on the table you want, basically. And then you start setting values using that arrow set keyword. Then you submit updates. There's also an async version of that. Let's see. I believe you can query update values like you did with the create one, and then submit update also. So it does support that. I just don't have the example. Yeah, like I said, there are a lot of type providers out there, or they're useful on a wide range of things, like a JSON provider, CSV provider, especially if you're doing like data science or something where you're trying to just go extract this out of here, extract that out of there, merge those together. It allows you to have strongly typed access to all sorts of data very easily.
Do they have somewhere the information how to write your own providers?
I think they have documentation on that, but I haven't looked into it. I know it involves meta programming, and it's probably further than my level of F# at the moment, so I haven't really looked into it very much. But yeah, I'm pretty sure there's documentation out there, or some books. So, F# async. So F# has an async workflows feature. Let me show you the example. So Thomas Petrusek, which is one of the well-known people in the F# community, had an example out there that I just took. But so the async workflows, basically, you're going to have a chunk like this, async, where you surround some other code with that in the brackets here. Where did that end? I think, yeah. So this one, for example, you can see this. This is a internal function to that other function that is recursive and also asynchronous. But it basically, as you can see here, return bang download. Anything in these workflows that you see that's like you see let bang, return bang, that's similar to an await call in C#. You can kind of think of it like that. I don't think that they're the same, but as far as like a beginner mental model, just think it's almost like return await, unwrap this task. So basically, asynchronously read length bytes into the buffer from the stream, write to another buffer, and then if the count was greater than 0, try to keep reading and do all of this asynchronously, and it just keeps calling that function until it's done. So here we do bang download, so that will wait until it's done reading and writing from that buffer. Let me show you up here, download page. So we create the request. Use bang is basically get a response. It's like a using statement, and then again, bang is like await. So asynchronously get the response. We're going to dispose of it when we're done. Using statement basically on the response stream. Create the memory stuff, do the download, seek to the beginning of that stream, read it to the end, pull out the title with a regex match. Here, again, we do this asynchronously. We asynchronously await the results of downloading google.com, bing.com, and yahoo.com. We map those all into this download page, and then we do them in parallel and await those results. So let's see. And then here we actually say run this whole deal right here synchronously. So whoops. There we go. So the Yahoo one, every time I've ran it, it doesn't have the title, but you can see it did grab these guys and extract the title out, and it gives us the length of the page. Here's an example I took off Wikipedia. Basically calculate whether something is prime. We have a function to do that. Let's turn that into async. Just wrap it in an async and return the number we did and run the calculation on that number. And when we wrap it in async, it doesn't immediately begin running. It's like the recipe to asynchronously do that. So then basically I can do primes mn. It creates a sequence of numbers from m to n, maps that through, so basically creates the the recipe to asynchronously calculate those primes, executes it in parallel, or creates an async task that will execute those all in parallel, and runs that task synchronously. And then that returns an array. Filter SND is actually a function that extracts the second value out of a tuple. So it basically extracts whether or not it's prime. So it filters based on only the prime ones. And then it gets you the first thing out of that tuple, which is the number. So here, print all these guys out. So these are primes between whatever the example said. Let's see. So Let me go back here. Got a couple more examples. Well, let me see where I'm at. So the thing about the async and task in C# is that they're composable, which is most functional programming is emphasizing composability. Locking is not a composable thing. It's hard to get right, and even if you do, if you have to add in new parameters and new things that are going on in the mix, you have to completely redo that. Immutable avoids writes to shared memory, so locks are not required. Mutable requires locks. Tasks in C# are nice, but there are a few pitfalls, and F# does not fall victim to them. There was a, it's moving on. Hold on, don't scroll. There's a blog post by Thomas Petracek. All right, basically saying why they don't fall victim to those pitfalls. Another thing that I'd like to mention, those workflows like the async keyword, it's not really a keyword. It's a generic language feature. There are other ones that are implemented as well, like seek, which is used for like IEnumerable stuff. And you can also implement your own workflows to do stuff behind the scenes when you call like let bang or that sort of stuff. I haven't done that, so I don't have an example on that. But it is a feature that you can build your own workflows. So, unit testing. F# is great for unit tests because it allows spaces in variable and method names. You can have human readable method names for your unit tests. It has some cool stuff like unquote, which allows you to evaluate F# expression or F# quotation, which is F#'s version of expression trees. And when the tests fail, it'll take you through the steps of evaluating that expressions tree. And I have an example of that in a second. And there's also FSCheck that facilitates property-based testing, which is kind of like fuzz testing by generating random inputs for your tests. So let me show you this. Oops. So this is from an F# for fun and profit article. One of the low risk ways to use F# at work. Pretty simple. Actually, I'm not running this one interactively. So we use endunit, say that it's a test. This is actually the function right here. I just use these double backticks, and then I can have spaces, and it doesn't complain at me. This test is a function that takes a F# quotation, which right here, this is a quotation, the bracket at. And so I can give it an expression, and it converts it into an expression tree that it can then evaluate. So this test should fail. 2 + 2 × 3 is not equal to 12. So if I go here and run all unit tests and bring this over, and the build failed. What was that?
No, it won't
No,
see
that's
time.
it sees the CD now.
Of course.
Just gotta change the colors.
We'll get rid of that.
It just took a while.
So you can see the first one passed. The second one, it actually prints out the results of the steps of evaluating that. So you can see it's 2 + 2 × 3 is 12. Then you can see now the next step is 2 + 6. So then it evaluates that down to 8 = 12, and obviously that's false, and the test fails. So I don't know. I think that's pretty cool that it shows you the steps on failing tests.
So is it going to go through all this step if I have my, let's say I have a regular C# classes and, functions and whatever, And in my test, I'm using this top level function. Will it go through all the stack trace and read the results for each step or not?
That's a great question. I don't know. I don't know if F# can just reach into that code and go, yeah, I can create an expression out of this, or not. Maybe. I'm honestly not sure on that. Yeah, I don't know. But again, this is pretty handy. You don't have to have like the overload of that test attribute where you can give it a human readable name and then duplicate that with underscores in your test. You can have human readable printouts by default. And I don't have an example of that FS check, but it just basically randomly generates, like you can tell it, do 100 just randomly generated inputs to this test. This test should pass no matter what those are. So it can be really helpful for fuzz testing your stuff. Let's see. So, when is F# a better choice than C#? Could be any time. It really depends on your preference and your needs. Definitely when doing data science and you need to query multiple disparate sources of data interactively in a strongly typed manner, I don't know if there's anything that's going to beat F#. It's also more suited for building DSLs and doing metaprogramming. Like pattern matching and F# quotations are really powerful for metaprogramming, so it's more at home there. But again, back to those beating the averages in the Python paradox, maybe F# could be your company's competitive advantage. It might be something worth looking into. Also, I want to mention F# is fully interoperable with the existing .NET code, so you don't have to choose an all or nothing approach. You can use your existing .NET code and try it out in unit tests. So a language that gives you the tools to build small pieces in isolation and easily compose in predictable ways makes you more likely to do the right thing. So functional programming is all based off of simplicity and composition, building small units and gluing them together. So for starting down your F# path to Zen, I've got a couple books and sites on here that I'd recommend. Real World Functional Programming with examples in C# and F#. That's written by Thomas Petracek, he's now a PhD. He worked at Microsoft Research with Don Syme, and I think he worked on a number of features in F#. And John Skeet, who they're both like the Chuck Norris, respectively, of F# and C#. And it has like side-by-side examples of like, here's what F# is doing, here's how you would do something similar if you can in C#. F# for Fun and Profit, that's a really excellent website. Lots of really good articles. It's going to be a little less structured than a book, but there's also a free ebook, I think. And he might be working on an actual book also that's not just a copy of the site. Suave Music Store, that's a Git book. Check that out. Let's see. The F# Deep Dives is a book authored by a number of industry experts on interesting features and uses of F#. It's kind of advanced. A lot of the stuff was over my head when I first got into F#, so if you're looking to get into it, you might hold off on that till you're comfortable, but there's some good stuff in there. And then Rich Hickey's Greatest Hits, just Google that. He's the designer of Clojure, the Lisp dialect that runs on the JVM. It's a fairly popular functional programming language. He just has some talks that kind of go over the mindset and why you should think about doing things functionally. So, any questions?
Question is kind of more philosophical, because I was playing with the F# like half a year ago and coming back to it again. My biggest struggle was switching my mind from actual procedural to functional, like, I wrote some code for my home project, and I noticed I have a big badass, your regular, basically, C# application with the F# syntax.
Yep.
Then I started to refactor it and end up a lot less code, but can you suggest something on basically where to exercises or maybe the books to actually get into this mindset for functional?
I would say that real world functional programming would be a really good place to start. They kind of talk about that and, how to think functionally and kind of interoperate in the imperative and OOP stuff. Like, if you need to code in that, do it over in this section and then come back into the functional world and stop changing values once you get back into that. But they definitely talk on how to think functionally, and it is definitely a mindset change. You do things differently doing functional, but I think that if you're interested in doing learning F#, definitely check out F# for Fun and Profit. That has some really good introductory stuff as well, but the real world functional programming, I think will be a lot more familiar because you'll see the F# example side by side, but they do talk about that philosophy of functional programming as well.
Do you guys run into many clients that are open to using F# or even require it?
Not that I'm aware of, no.
Okay.
Yeah, I think it would be somewhat new. Yeah, but got to start sometime.
That's right. It's a big shift though.
Yeah.
Looks like unit testing is a safe place to start.
Yeah, that's true.
We've already planning our way home.
Yeah.
Yeah, the low risk ways to use F# at work. There's also a bunch of other. It's not just the unit testing. I mean, he talks about using like the SQL type provider to do database administration type stuff and just creating scripts. F# is you can do a .fsx file and run it from the command line using F# Interactive and just use it as a scripting language. So you can write scripts using it too. So you can do computer administration. I think there's a WMI type provider, and you can do Windows administration using F# scripts. I mean, there's just crazy stuff. So he has like tons of ways you can use it outside of code too for your just personal tasks that you're doing. So definitely, check that stuff out. Any other questions? Thank you, guys.